Okay, let's continue with our next part on differentiation. That is to find first derivative of a function f(x) by using first principle. So let me introduce you. The first derivative means dy dx. Okay, so dy dx is a command, okay, to differentiate function y with respect to x. Okay, so dy dx is a command to differentiate function y with respect to x. So dy dx is called the first derivative. So we have to run the process on differentiation. Okay, but here we need to find first derivative or define first derivative of a function of f(x) by using first principles. So using first principles means we need to use the concept of limit, that is to find limit delta x approach 0 for delta y over delta x. Okay, the symbol delta here is a small change. Okay, so delta y means small change in y, and delta x means small change in x. Okay, so our variable x and y will have a small change and it will become the new value. Okay, if the first value is x, the original value is x, so after a small change it will become x plus delta x. Okay, so we are going to find the first derivative of a function f(x) using the first principles. Means we need to use to find dy dx, okay, using limit delta x approach 0 of delta y over delta x. Okay, so let's say we have a function of y equal to 2x. Okay, this is the original function. So when x change, the value of y will change. Okay, so now if we have a small change in both variables, so we will have a new value or a new relation for the new value of the function. Okay, the variable, so the function is become y plus delta y equal to 2 and then x plus delta x. Okay, the value of y will change to y plus delta y and the value of x will change to x plus delta x. Okay, and the constant 2 remains. Okay, so this will be the first step where we need to find a new relation for both changes in x and y. Okay, and then we expand, okay, the right hand side. So we have the equation of y plus delta y equal to 2x plus 2 delta x. Okay, now we have two equations. The first is the original equation. So after small change, okay, in values of x and y, so we have another relation, okay, that relates y plus delta y equal to 2x plus 2 delta x. Okay, so that will be the first step, okay, to find the new relation for both for the function when both variable x and y have small change. Okay, next, the second step is to solve the simultaneous equation, okay, where we need to reduce the y. Okay, so we need to have delta y because we need to find limit of delta x approaches 0 for delta y over delta x. So we need to have the term of delta y. So in order to find delta y, we have to eliminate the y. So let's solve the simultaneous equation between the two equations. So equation 2 minus equation 1. So y minus y, okay, is 0. Then the left hand side will be left with delta y. Okay, so let's look at the right hand side. We have 2x minus 2x. Okay, so 2x will be eliminated, and then we'll be left with 2 delta x. So we have delta y equal to 2 delta x. Okay, now we have the term of delta y. What we need to do now is to find the term of delta y over delta x. So we need to continue with the third step, where we need to divide both sides with delta x. So when we divide with delta x, we will have delta y over delta x, okay, equal to the right hand side, we will have 2. Okay, and finally the last step, okay, we can find dy dx, okay, using the theorem, that is dy dx is limit delta x approach 0 of delta y over delta x. So we use the theorem to find the first derivative, okay, dy dx. So our dy dx is limit delta x approach 0. Okay, our delta y delta x is 2. So we substitute 2. And then we need to substitute delta x with 0. But here we don't have any delta x term. So we just continue with the answer as 2. So dy dx for function y equal to 2x. Okay, after using the first principles, we will have the dy dx, or the first derivative, is 2. Okay, so find the first derivative, find dy dx. Using first principles means we need to use, okay, the theorem limit delta x approach 0 of delta y delta x. So these are the 4 steps on finding first derivative by first principle. Okay, so please remember the 4 steps. Okay, next, okay, we look at the relation. Now dy dx, okay, is also using limit delta x approach 0 of function, okay, x plus delta x minus function of x, okay, and then divide delta x. So here we have combined the first, second, and third steps all together, becomes 1. Okay, and then we strictly use the limit, okay, of delta x approach 0 for f x plus delta x minus fx over delta x. So it means we need to find the function or the value of f x plus delta x, means you have to substitute, okay, the object as x plus delta x, and then we have to minus with the original image, okay, fx. Okay, now next example, okay, the next exercise, I'm going to find dy dx. Okay, so we need to find dy dx using first principles, okay, for each of the following functions. Okay, now I'm going to use okay, the theorem dy dx, finding dy dx, okay, using the first principles. So now I'm going to use the second relation, okay, where we use limit delta x approach 0. Straightly we combine all the first 3 steps together. So we find f x plus delta x, and then minus fx, and then we have to divide with delta x. Okay, now so look at the first function. We have y equal to x. Okay, so finding dy dx means finding dy dx using limit, okay, of delta x approach 0. So for f x delta x means, okay, f for object x plus delta x So we substitute into function f. So we have x is our function, okay, our y or fx. So when we have x as x plus delta x, so meaning it is x plus delta x. And then we minus with fx. So fx is x itself, so we minus x. And then divide with delta x. So here when you expand, you will have x minus x, okay, 0. Then we simplify the equation, so the function, sorry. So we will have limit delta x approaches 0 of 1. Okay, because delta x over delta x is 1. So next we need to substitute the delta x with 0, but we don't have any delta x term. So we proceed the answer with 1. So this is dy dx using first principles, using the concept of limit. So the value of dy dx is 1, or the first derivative is 1. Okay, you can try B. Okay, so for B, okay, using limit delta x approach 0 for fx plus delta x minus fx over delta x. So let's substitute 5, the x with x plus delta x. And then we have to minus fx itself, that is 5x. And then we divide with delta x. So when we simplify the function, we will have limit delta x approach 0 of 5 delta x over delta x. So delta x over delta x can be simplified. So our answer is 5. Alright, so this is much easier. Okay, next, let's look at C. We have y equal to negative 4x. So we need to find the first derivative, okay, using the first principles. So meaning we need to find dy dx using limit delta x approach 0 of fx plus delta x minus fx over delta x. Okay, so once again, let's use the theorem. Okay, so dy dx, the first derivative of y, or differentiate y with respect to x, is using limit delta x approach 0 for negative 4. Okay, x now is x plus delta x minus, okay, fx is negative 4x, and then divide by delta x. So when we simplify the function, we will have limit delta x approach 0 of negative 4 delta x over delta x. So delta x and delta x can be simplified, and the answer will be negative 4. So this is our first derivative. Okay, so means dy dx is negative 4 by using first principle. Okay, so now let's look at D. Okay, what if we have a function of y equal to 6x squared? Okay, so y equal to 6x squared using first principles means we have to use, okay, the concept of limit. So dy dx is limit delta x approach 0, okay, of fx plus delta x, means our fx is 6x squared, so it becomes 6 and then x plus delta x squared minus fx itself, that is 6x squared. Okay, and then we have to divide with delta x. Okay, now let's simplify the function. So we have limit delta x approach 0. Okay, so we need to expand the quadratic. Okay, we have x squared plus 2x delta x plus delta x square. Okay, so delta x is one value, which is the small change in x. Okay, and then we minus with the function itself, minus 6x squared. And remember to divide all this with delta x. Okay, when we expand the first expressions, we will have 6x squared, and then 6x squared minus 6x squared. Okay, so it will be eliminated. Okay, it becomes 0. So now we have 6 and then multiply with 2x delta x and then plus 6 delta x square. So here we have limit delta x approach 0 of 12x delta x. Okay, 6 times 2x delta x, so 12x delta x plus 6 times delta x square. So here we have, I missed the 6. So we have 6 delta x square. Okay, and then we divide by delta x, so we will have limit delta x approach 0 of 12x plus 6 delta x. Okay, so simplify. Okay, means we can simplify delta x with delta x and another delta x. Alright, so when we substitute delta x with 0, okay, means the term 6 times delta x will become 0. So our answer is 12x. Okay, so this is finding first derivative using first principles. So you have to make use of the concept of limit. Okay. Right, you need to be careful along the process of expansions and simplify. Alright, so make sure you calculate correctly your algebraic expressions here. Okay, now the next one. Okay, so the next, we just look at the answer. So we have y equal to negative x squared. So finding dy dx is limit delta x approach 0 of negative. Now our x is x plus delta x squared and then minus negative x squared itself and divide by delta x. Okay, this is by using the relation of limit. Okay, using the limit. Okay, next we expand our expressions in the numerator. So we will have negative x squared and then minus 2x delta x and then minus delta x squared, and then the last term is plus x squared. Okay, and we have to divide all this with delta x. So when we simplify, we can see that negative x squared and plus x squared at the end will become 0. Okay, and then we divide these two terms with delta x, so we will have negative 2x minus delta x. Okay, delta x squared over delta x, we have delta x. Okay, now we substitute delta x with 0, so the answer will be negative 2x. Okay, be careful along this process. Okay, where you have to expand and simplify. Okay, so next we look at the function of y equal to 2x cubed. Okay, 2x cubed. Okay, so dy dx is limit delta x approach 0 of 2, and then x will becomes x plus delta x cubed. Okay, and then minus fx itself, that is 2x cubed. Then we have to divide with delta x. Okay, here where you need to be careful, where you have to expand x plus delta x cubed. So it is x plus delta x squared times x plus delta x. So we expand x plus delta x squared, we will have 2x squared plus 2x delta x plus delta x squared. And then multiply with x plus delta x. Okay, and then remember the last term is to minus 2x cubed. Okay. Next, let's simplify. Before we simplify, we expand again, another expansions here. So we have limit delta x approach 0 of 2x cubed, okay, plus 3x squared delta x plus 3x delta x squared, okay, plus delta x cubed, then minus 2x cubed. Alright, so when we simplify, we can simplify the first term 2x cubed with the last term minus 2x cubed. Okay, next we expand the what's in the bracket with 2. So with 2 times 3x squared delta x, and then divide by with delta x, okay, we will have 6x squared. 2 times 3x delta x squared, and then divide with delta x, we will have 6x delta x. And finally, we have 2 delta x cubed divide with delta x. So here, I've left the 2. Okay, so 2 delta x squared. And finally, we have to substitute delta x as 0. Okay, so this is 0 and the last term is 0. So we have the answer as 6x squared. Okay, so the first derivative is 6x squared. Okay, so that is for function 2x cubed. Alright. Okay, so I leave G to you. Okay, you have to answer G. Okay, finding dy dx using the first principle. So next, we look at h, y equal to 1 over x. Okay, so using the first principle, okay, y equal to 1 over x. So to find dy dx is to use limit delta x approach 0, okay, of 1 over x plus delta x. Okay, we have to substitute x with x plus delta x, and then minus 1 over x itself, and then all this will be divided with delta x. Okay, now let's simplify the numerators. Okay, the numerator, the expressions in the numerator. So we have deduction of 2 fractions. Okay, we have a deduction of 2 fractions. So remember how to minus a fractions means you have to make sure the denominator of both fractions are the same. Okay, so here we will have, we need to multiply with x for the first term. So we have x over x times x plus delta x. Okay, and then the second term, we have to multiply 1 with x plus delta x. Okay, so this is the deduction of 2 fractions. Okay, so we will have x minus, okay, in bracket x plus delta x over, okay, the denominator becomes x times x plus delta x. Okay, because we have to make sure the denominator are the same, then only you can minus the fraction. Okay, and then from the first row, we have to divide with delta x. So when you have fractions, n fractions, means you have to change, okay, to multiply, okay, and this will be equal to the fractions times, okay, delta x over 1 will become 1 over delta x, okay, because I don't like to see there's too many fractions here, okay. If not, you have to write down over delta x. So straightly, I change it to multiply with 1 over delta x. Okay, now let's simplify the first relation or the first term. So limit delta x approach 0. Okay, x minus x is 0. Then we have negative delta x over, okay, this one x squared plus x delta x, and then multiply with 1 over delta x. So here we can simplify delta x and delta x here. Okay, so we have negative 1 over x squared plus x delta x, and then we substitute delta x with 0. Okay, so this value we substitute with 0. So the final answer is negative 1 over x squared. So this is our first derivative, dy dx. Okay, but we find the first derivative dy dx by using first principle. Okay. Alright, let's go to the next question. We were given with y equal to 2x squared minus x plus 7. Now we need to find dy dx by using first principles. Okay, so meaning we have to find dy dx using the concept of limit. Okay, so let's run the process. Y is 2x squared minus x plus 7. So dy dx, okay, will be the limit of delta x approach 0. Okay, let's substitute the x with x plus delta x. Okay, so the expressions will become 2, okay, with x plus delta x squared minus, okay, now x, the second term of x, need to be substituted as x plus delta x2. Okay, because we have to substitute all the value of x with x plus delta x. Okay, and then plus 7. Okay, this is fx plus delta x. Okay, and then minus with fx itself. So minus with 2x squared minus x plus 7. And you have to divide all this with delta x. Okay, now we have made use of the concept of limits. Okay, next, okay, the next step is really we need to be careful where you have to simplify the expressions. So when you expand the first expressions, we have 2, okay, this is quadratic, so 2x squared plus 4x delta x plus 2 delta x squared. And then open bracket for the second expressions, we have minus x minus delta x, and then plus 7 follows. Okay, and the last expressions follows, right? So now we simplify. So here we can remove 2x squared minus 2x squared. Okay, and we can remove the negative x minus negative x, and 7 minus 7. Okay, so here we have limit x delta x approach 0 of, and then we divide with delta x. Okay, 4x delta x divide delta x, we have 4x 2 delta x squared divide delta x, we have 2 delta x minus delta x over delta x is 1. Okay, so here I strictly simplify the expressions or the functions. And the last step is to substitute delta x with 0. So this will become 0. Okay, so the first derivative, okay, for the function y is 4x minus 1. So y is 2x squared minus x plus 7. By first principle, okay, dy dx is 4x minus 1. So I hope you can try the next question, okay, using the concept of limit, okay, for first principles. Okay, and be careful along the process of substitution and simplify. Okay, simplify the algebraic function. Okay, so I leave this to you. So hopefully you can find the first principle for curve y equal to 3 plus x minus x squared. Okay, remember by using the relation. Okay, and then you can further up your exercise on formative exercise 2.1. Okay, here you have question 1, 2, 3, okay, concept of limit, okay, until question 6. Okay, so this is to sharpen your skill on our first part, that is limits and the its relation, okay, to differentiation. Alright, so all the best. See you in next session, okay, in our first topic.